Okay, continuing on with section 5.2, day 1. This is the second video. And we are just proving our identities still, which means we're just going to get the left side to look like the right side. So again, you get to pick which side looks harder. Well, to me, maybe the left side looks harder because we have fractions and we have two terms on this one. So what do I do on the left-hand side when I want to add fractions? What needs to happen there? Well, we got to get common denominators. Since none of my fractions can factor, or excuse me, since none of my denominators can factor, and I get ready to find the LCD, it's actually going to just be each piece of our denominator, so each factor in there. So we're going to multiply top and bottom by the LCD. So to get our least common denominator, we got to multiply by what we're missing. So for my first fraction, I need the secant x plus 1 on the numerator and denominator, and for my second part of my fraction, I need to multiply by secant x minus 1. After you've done that, you're technically going to distribute and then combine like terms. So when you combine your like terms in the numerator, we're going to have this secant x and this secant x, and then the ones are actually going to cancel out with each other. If you want to write it all out, this is what it would look like: secant x plus 1 plus secant x minus 1. And then in the denominator, you can see that I actually FOILed the denominator. Now the denominator are conjugates, so remember with conjugates, we don't have to do the full FOIL, we just have to do first and last. And when you FOIL your denominator, you're going to end up with secant squared x minus 1. All right, continuing on, we need to pause, take a breath, look at the right-hand side. Do you see where they're coming up with a 2, a cotangent x, or a cosecant x? I'm not seeing it yet, so I'm going to keep pressing on. So looking back at my numerator over here, I'm just going to combine like terms. So I have 1 secant x plus 1 secant x. That's going to give me 2 secant x's. And then I have a negative 1 plus 1. Those guys cancel out. And then check out your denominator. This should look familiar to you. Go back to your notes, find your identities. What does secant squared x minus 1 give me? Hopefully you found that it equaled tangent squared x. That's one of our Pythagorean identities. So in the numerator, we have 2 secant x plus tangent squared x. Okay, again, pause, take a breath, and look at the right side of our problem. The right side of our problem is asking us to find a 2, which I now see a 2 popped up in my question. I need a cotangent x, and I need a cosecant x. So we're close. I'm kind of getting a feel for where this might go, but we're going to do a couple more steps here to make sure. And I decided to go right next door here. You're supposed to draw an arrow to where you're going. So on this one then, I decided to change everything to sines and cosines. And again, there's other ways you could do this one, so if you want to try it a different way, please do. But I decided to change 2 secant x. So I want to show you what this looks like. So on the side here, 2 times secant x. Well, if we want to change the secant x into sines and cosines, it's going to be 2 times the reciprocal rule, which is 1 over cosine x. And then tangent squared, you guys should remember that one from the other day. That's our quotient identity. That's just sine squared over cosine squared. So I changed everything in my problem to sines and cosines, and this is what we end up with. Okay, pausing, taking a breath, looking at the right-hand side of our problem. Again, I need 2 cotangent x, cosecant x. I still have the 2, but now I got to figure out how do I get cotangent x and cosecant x. All right, back to our problem. I have a fraction divided by a fraction. So you guys should know fraction divided by a fraction. All we got to do is flip and multiply. So we're multiplying. I can just draw that as one giant fraction. I see a cosine x in the denominator and a cosine x in the numerator. So now I'm left with 2 times cosine x, and then I specifically changed the sine squared x into sine x times sine x. I'm doing this for visual purposes right now, just until we get used to it. All right, pause, take a breath, look at the right-hand side. We need a 2, a cotangent x, and a cosecant x. If you go back down to our problem, we still have the 2. And the reason I split that sine squared up is so that you could see this right here. That's the same thing as cotangent. So I can rewrite this, and I'm going to draw my arrow here so I know this is where I went. 2 times cotangent x times 1 over sine x. Pause, take a breath. Do you see it yet? We've got the 2, we've got the cotangent x, and the only thing I need left is the cosecant x. And we can just use the reciprocal rule to get the cosecant x that we need. So we have 2 cotangent x, cosecant x, which is the right-hand side of our problem, and we are done with that example.